Hey, geometry people. So yesterday, or not yesterday, last week, we talked about areas and circumferences of circles and things like that. So today we're going to talk about areas of triangles and other and quadrilaterals and things like that. So we have a lot of different area formulas to go through today. So here we go. Triangles. So you might remember from elementary or middle school, area of a triangle. You might not. Is base times height divided by 2. You might have also have heard of it as 1/2 base times height. So that's area for triangle. So let's see what that looks like for us. It kind of depends on what triangle you're looking at as to what the height and the base will look like with each other. But a good rule of thumb is that the base is always perpendicular to the height. So the base and the height are always going to meet at a right angle. They're always going to meet at that 90 degrees. Okay, so if you are tempted to call something the height that is not 90 degrees with the base, make sure we don't. Make sure we look for the spot where a height would be perpendicular to the base. Okay, so here we go. If I've got just your basic triangle going here, the bottom, just as a note, the bottom side isn't always the base. In this case, if I know that this side is, 8 centimeters long or something like that, it could be the base. And then the height is not going to be one of these two sides. Like, even if I know that this side is 4 and this side is 6 or something like that, neither of those sides are perpendicular to 8. So the height instead would have to be something that you drop down from the opposite corner. Okay, which hopefully makes sense, right? You don't measure height, so when you're leaning over, you don't go to the doctor's office and get your height measured, and you don't like lean to the side while they're taking your height measurement. You stand up straight, right? So we want a straight line from the opposite corner to that base, and it needs to be perpendicular, not leaning over. Okay, so this would be my height, and we'll say that the height is 5 centimeters. Okay, so if I wanted to find, so don't be fooled by any extra measurements on there, these two are the only ones that you need. Okay, so to find my area of my triangle, now all I have to do is plug things in here, base times height divided by 2. So area would be the base 8 times the height 5 divided by 2, which is 40 divided by 2, which is 20 centimeters squared. Make sure that whatever units you use, they are squared because we're talking about area here today. So there we go. Okay. There's other ways that we could see heights within a triangle. For example, if you have a right triangle, like this, then we have two measurements of the triangle that are already perpendicular to each other. We have this side and this side, right? So if this was 4 and this was also 4, this would be our base and our height because we know they are perpendicular to each other already. If we have a triangle like this, and you want to use this side as the base, let's say it's 7 inches. If we want to use this side as the base, I can't draw a line from this corner landing over here that's perpendicular. They're all going to end up being slanted, right? But if I extend this base and we have some extra pretend base over here, then I can drop my line down, and this would be my height. So only this portion would still be my base, but this would be the height. I wouldn't like add in anything over here, anything like that. So this would be my base, this would be my height. Okay, so those are just some different pictures that we can see in triangles with their heights. One other type of problem that you might be asked to do with a triangle is you might be given the area and one of the measurements and asked to find a different measurement. So let's do one of those really quick. Like, let's say I know that the height is 3 inches, and I know the area is, let's go with 5 square inches. I don't know. Okay, so our area is 5 square inches, and we also know that area is equal to base times height divided by 2. So now all I have to do is plug in the height that I know to solve for the base. So I'm going to plug in 3 here, and then to get rid of my fraction, I'll multiply by 2 on both sides. So 2 times 5 is 10. Those cancel, and we get b times 3 over here. Then we want to divide by 3 on both sides, and we get 10/3. Or you could rewrite it as 2 and 2/3, or sorry, 3 and 1/3. Yikes. Or you could write it as, if you're asked for a rounded decimal or something like that, 3.3 repeating. Anything like that would work. Typically, if you're doing it in IXL and they ask for exact form, just put it as the 10/3. That's fine, as long as your fraction's reduced. But yeah, that's another type of problem that you could see. Okay, so let's go through some of the other area formulas that you're going to be asked to use today. Okay, so there's our triangle one. We'll leave that there. Next one that we want is for squares. Area for a square is just the side length times the side length, or the side length squared is what you might also have for that one. This one hopefully is fairly simple for us. We might even remember it already. If we know this is a square and our side length is 2, we plug in 2, and 2 squared is 4, so this would be 4 square inches. Okay, so there are squares. You might be asked to do the same kind of thing there. If they give you the area, like they say the area is 49 and they want to know the side length, then all you would do is square root the area and it would give you the side length. All right, next one, rectangle. Hopefully also pretty straightforward and simple for us. Area is length times width. Or you might also see it as base times height. Doesn't really matter which notation you use for that. If you've got a rectangle and you know this side is 10 and this side is 3 centimeters, then all you do is multiply the two numbers and you get your area. So 3 times 10, which is 30 square centimeters. Okay, so there's rectangles. Now we're going to go with any parallelogram. All right, area for a parallelogram is actually the same as that for a rectangle, but not in the way that you think of it always. So base times height is the one that we're going to use for parallelograms, and it is important that you use base times height here instead of length times width, otherwise we might get a little bit confused on some of the measurements. So here we go. Here's our parallelogram. Now I might know all kinds of information about it. I might know that this is 7 centimeters and this is 15 centimeters and this is 10 centimeters. No, that can't be 10. Just kidding. 5 centimeters. So we might know all kinds of information like that, but my base and my height are not necessarily these two. In fact, unless it's a rectangle, it won't be these two. Instead, we have to remember back to triangles where we had the base is perpendicular to the height. That also holds true here. So if 5 is my base, or sorry, 15 is my base, then 5 is my height here. So here's our base, here's our height. We don't need this piece of information. So now all we have to do is go 15 times 5, which is 75, I believe, centimeters squared. Okay, so there's parallelograms. There's also a formula that you can use for a rhombus that's a little bit different. A rhombus is a parallelogram, just like a rectangle and a square are also parallelograms. So for a rhombus, sometimes it just depends on the measurements that you're more likely to have. Area is diagonal 1 times diagonal 2 divided by 2. So you can use this formula. You could also use this formula if you happen to have the base and the height. But sometimes in a rhombus, again, this is the more likely measurement that you might have. So remember, in a rhombus, it looks just like a regular parallelogram, except all the sides are the same, right? And the diagonals, bisect each other just like they do in any parallelogram, stuff like that. So let's say that we have measurements like this. This is one of our diagonals. It's from corner to corner. Let's say that diagonal is 10, and this diagonal is 4. So diagonal 1 times diagonal 2, doesn't matter which one is which. 4 times 10 divided by 2, which gives us 40 divided by 2, which is 20 square units. But let's say they gave us something different instead. They didn't give us directly the diagonals. What if instead they gave us like half of the diagonals or something? Let's say they gave us 5 and 6 or something instead for this length and this length. Well, then we know that this diagonal is twice this number, this diagonal is twice this number. So this diagonal is really 10 for this whole thing. And this diagonal is really 12 for this whole thing. So then we just carry on from there. But we want to remember that property about a rhombus. Okay, the last shape that we're going to do for today is the area of a trapezoid. Can we still see down here? Yes. Okay, for a trapezoid, the area is base 1 plus base 2 times the height divided by 2. You might also see it written as 1/2 times base 1 plus base 2 times the height. Either way of representing it there is fine. Just remember that where we have parentheses, we need to remember our order of operations and do the adding of the bases first. Okay, so let's take a look at a trapezoid real quick and do an example here. Lovely trapezoid. Okay, so the bases. The top is one of the bases, the bottom is the other base. It doesn't matter which one's base 1, which one's base 2. And then the height has to be perpendicular to both of the bases. So that's very important. One of these sides may or may not be the height. Depends on how it's drawn. If you have a trapezoid that looks like this, then yeah, this is the height over here. But if you have it drawn like this, then this is the height. So it really just depends. So let's say that base 1 is 4, base 2 is 6, the height is 5. Okay, so we would go base 1 plus base 2, so 4 plus 6 times the height, which is 5, divided by 2. So now we have to do our 4 plus 6 first, since it's in parentheses, which gives us 10 times 5 divided by 2, which is 50 divided by 2, which is 25 square units. Okay, So there's our area of a trapezoid. Occasionally, you'll see on a trapezoid, you'll see that you're given an alternative measurement. They'll give you the height, and maybe they'll say the height is 7, but then they'll also give you this median, and they'll tell you that that distance is 10 or something like that. So one interesting thing is that base 1 plus base 2 divided by 2 gives you this median distance. So the area of a trapezoid could also be the median times the height, which is nice. It just cuts out a lot of work for you. So if you are given that distance, that length of the median and the height, you can just go 10 times 7 and get 70 here. So that just makes everything a little bit easier. But most of the time you'll see you're given the bases and the height instead. Okay, hopefully this was helpful. Here's all of your formulas here. Make sure you write those down before you go. And then if you have any questions or anything like that, email me, comment, or show up to office hours. Have a wonderful day.